Today's lesson is 15.3, Changing Momentum Quickly. So drivers normally can drive at about 100 kilometers per hour, usually like on highways, for example, the Deerfoot as well, and they can stop safely without injuring themselves or damaging their vehicles. Imagine the force you would feel if your vehicle went from 100 kilometers per hour, which is 28 meters per second, to a complete stop in less than 1 second. That's what basically occurs in a crash. So the forces involved are great enough to crumple metal, shatter glass, and splinter bones. Fast stops require a large impulse that results in an immediate change in the momentum. A large amount of force is required, and this force is what causes injury and property damage during collisions. Okay, so here we're looking at two figures. In this figure, the car is traveling at 100 kilometers per hour. It's a gradual change of speed to get to that stop sign, so therefore there's less force. All right, and then so car A, this is car A, it braked and stopped over 25 seconds to come to a complete stop. Car B, traveling at 100 kilometers per hour as well, ran into a brick wall and stopped in 1 second. So which driver will experience a greater force? It would be car B. So today's class we'll be looking at calculating force. So when an impulse occurs, momentum changes. So usually the mass will stay the same and the velocity changes. The amount of time it takes to change velocity determines the force involved. So it takes more force to stop a car going 100 kilometers per hour in 1 second than it does to stop the same car in 25 seconds. So our formula for force is mass times the change in velocity divided by time. So let's take a look at this example. What force is involved in stopping a 1,200 kilogram car traveling at 100 kilometers per hour in 25 seconds? So we know the mass. The mass is 1,200 kilograms. We know the change in velocity because the final velocity is 0 meters per second and the starting velocity was 28 meters per second. Okay, so if we do 0 minus 28, that gives us negative 28 meters per second. And basically that negative just means that the vehicle is slowing down. All right, and the time is 25 seconds. All right, so we use meters per second because we're also using time as seconds. And what are we trying to find out? We are trying to find out the force involved. All right, so we have everything we need to know. Our formula is mass times change in velocity divided by time. So 1,200 kilograms times the negative 28 meters per second and then divide it by seconds, 25 seconds. Okay, and once you put that in your calculator, you will get negative 1,344 kilogram meters per second squared. So that was the force. So the car experienced a negative, or it's the braking force, of 1,344 kilograms meters per second squared. And if we go back to our diagram, this is car A. So car A, which stopped over 25 seconds at the stop sign. Okay, so seatbelts, airbags, and other safety features help to slow passenger momentum even when the car experiences a large impulse. The car and passenger experience the same impulse during this crash. The car experiences the impulse in a very short time. It's a large force. The passenger will feel it over a longer time because of the seatbelt and airbag. It will slow down the momentum gradually. So keep in mind, more time equals less force. All right, so the 15.3 questions are on page 280, numbers 1 to 3, but there are also the Math Connect questions on page 278. These are the ones where you will be calculating force.